Hello everyone. So let's just start with our first topic today of fixed size sliding window. So if you have not watched the first video of the sliding window playlist, just go and watch. I have covered what all things I'll covering in this sliding window playlist. Okay. So our first topic will be fixed size sliding window. I would suggest if you do not have any idea on what is sliding into, it's better if you read some GFG document or some playlists. There are so many playlists of basic sliding windows. Okay, uh, how we will use it. Okay, what is the window and all those stuffs. I'll be covering it, but not in very deep. I just wanted to cover different variations of sliding window rather than just focusing on basic sliding window. Okay, so let me just tell you what sliding window is. Sliding window is usually a technique which is used to reduce the time complexity of problems which involve continuous subarray or substring related problems. Okay, so it's basically used in continuous subarray or substring related problems, and you have one moving window which you will use to calculate it. So basically it is used if you have some repetitive task. Okay, as this is fixed size sliding window, so it will be used for repetitive task for fixed window size of k. Okay, now you might think that we have learned the subarray related problems using map and prefix sum also in our prefix sum playlist, and this is also the same like sliding window. So when to use prefix sum and when to use map. So when fixed condition k is given on sum of subarray. Okay, there we are doing sum of subarray because we are always taking care of some subarray, some subarray of L to R is given as k, and then we have that formula of prefix of R minus prefix of L minus 1, and then we'll calculate on basis of map. So that can be given if it is given on this, if the condition k is given on sum or addition of some subarray. Okay, so there we can use prefix sum. Otherwise, what we will use? Otherwise, we will use sliding window. So now, while solving the questions, you will be able to know what type of k conditions will be given. So it could be asked to return the vector. Basically, it could be asked to return vector where each value in the vector answer should be some calculation on k window size. Okay, that could be some basic question. Or minimum length or maximum length of subarray could also be here, the same as what we have. Okay, on prefix sum, but here the condition of k is not on sum sum, that is addition of subarray. It's something different. The condition is something different which you will know as and when we solve the question. Okay, so the basic question of the fixed size sliding window is, let's say you will be given one array. Okay, so let's say this is your array 5 4 7 6 1 2. This is your array of size 6. Okay, and your k is equal to 2, so you have to return an answer vector where each I index should contain first k indexes from I, first k indexes of this array, sum of this first k indices. So that means that you have to take first 5 and 4. The sum is 9, so this should be 9. And then this 4 and 7, so 7 8 9 10 11, so this should be 11. And then 7 plus 6 is what? 13. And then 1 plus 2 3. Sorry, 6 plus 1 7, and then 1 plus 2 3. Okay, so all window of size 2 you have to consider. So why we will use sliding window? Because there is repetitive task. If I say simply this 5 plus 4 is done. Okay, now no need of doing 4 plus 7 separately. You know what is the summation of 5 plus 4. So you have to add 7 in that sum, and you have to remove 5 from that sum. So now you have to take this much sum. So you have to add one new j in your original sum and remove um, one I from previous window. Okay, so this is the repetitive task, and that's why we will use the window. We will slide the window as and when we move forward. We will slide the window in this direction as and when we will move forward. Okay, so let me just give you one another question which we can solve. So this question is, you are given a k size window, and now you do not have to find the sum of all, you have to find the maximum sum from all window of size k. So like after calculating this, the maximum will be 13. So you have to return those 13 over here. So what we will do? So let's just go to the template on how we will solve this type of questions. Okay. Let's just go to the template on how we will solve this type of questions. So we will take two variables, I and j. J will move forward and I will be the number which you have to remove, and j will be the number you have to add always. Okay. J is the part of continuous loop, I can say, and I is the part of window or number to remove. Okay, number to remove or slide the window or whatever. Okay, so what we can do is, now just remember your window size will always be what? J minus I plus 1. So let's say your j is at 4, means at index 1, and your I is at index 0, then your window size will be j is 1 minus I is 0 plus 1, 2. So your window size will be 2, correct? This 2. So window size is always what? J minus I plus 1. And here for fixed size, you will be always given the size of window, which is k. Okay. So two things we need to take care. Two things we have to take care. First, if my window size, which is j minus I plus 1, is lesser than k, then we have to do nothing. Just move the loop ahead. Okay. Else, what you have to do? Else if you have reached the window size. Okay. So this is your window size. You have reached to the window size. Then calculate your answer. Okay. In whatever way you have to calculate, just do the calculation. You have to do some initial calculations above also. Okay. So like here what we have to do? We have to take the sum. So we will do the summation over here. Okay. Like summation or increasing the character in map or increasing count. Okay. As and when, depending on the question, you have to do your calculations over here. Now if window size is equal to k, you have to calculate answer. What does my answer mean over here? Maximum sum. So I'll calculate max sum. Or if I want to store each and every answer in my answer array, like this above question, then I'll store an answer array. Okay. This you have to do when you are satisfying the window size. Okay. So we'll calculate our answer and then we will slide the window. We'll slide the window. So whatever operation we have done above, whatever operation we have done above, let's say this is the calculation A which we have done above, then we will do the opposite of this calculation for ith index. This is how you will slide the window. So let's say you have added your nums j every time in this summation. This is what your calculation. So let's say your calculation A is sum plus equal to nums j. Okay. Then here what you have to do? The opposite of it for nums I. So you have to minus it from ith index. This is how you will slide the window. And then you will do I plus plus and j plus plus also over here. Done. This is your fixed size sliding window template. I hope I'm clear with the template. Okay. So without wasting, let's just code what we have. So what will be the code part for this question, where we have given k size window and we have to find the maximum sum from all window, from all window. So let's say your array is given as 2 1 5 7 6 3 2 5. Okay. And your k is 3. Let's say your k is 3. And what we will do? We will take ij0. We will take one maximum answer also, which is again maximum length. Again, we have put 0. We will run one loop for j. So we will do while j less than n. This loop will be for j less than n. It would be better to take the while loop over here. Okay. So we will do while j less than n. First, we will do the calculation part. So here our calculation will be, we'll have one sum variable also here. Okay. So we will always do sum plus equal to nums of j. Okay. Here array of j. Now we will check if our window size is less than k, will not do anything. But if we have rich our window size, then what we have to take? Maximum of all such windows of size k. So we will calculate our maximum answer to be maximum of what we have got previously and the sum. And now every time as we have reached this window size, for next window what we have to do? Of course, this will be done. The j part will be added as and when you go. So the left is we have to remove the ayat part. So now we will remove the ayat part. We will do the opposite calculation. We'll do I plus plus also and j plus plus also. Clear? This is how we will do, and our max answer will be the final answer. Okay, let's just see how it will work. I'm doing it over here. So initially you are at 2, your j and I is 0, 0. Okay, so you will do sum is equal to 2. J minus I plus 1 is will be 1, which is less than k. So we'll do nothing. We'll do just j plus plus. I is still at 0. Okay, just remember. Now we will add 1. So answer will be 3. Sum will be 3. Again, j minus I plus 1 will be 2. The window size is 2. So we'll not do anything. Now we are at 5. So what we will do? 3 plus 5 will be 8. Now j is 2, I is 0. 2 minus 0 plus 1 is equal to 3. So we will do max is equal to, initially max is our 0. So it will be 8 now. And now from this sum, we will minus what? This ith index 2, which is 6. So now the sum remains 6. And now my I will be at, 1. Okay. And our j is, and j will also be plus plus. So j will come at 7 now. Okay. We will do sum plus equal to this. The 7 will be added to this. So it will become 13 now. Again, j minus, now it will always satisfy j minus I plus 1 is equal to k only, as you know. Okay. So this maxi is 8 comma 13 is what? 13. We'll remove 1 from this. So 12 will be removed. I will move forward and j will also move forward, and it will come to 6. We'll add 6. It will become 18. Of course, 18 is more. So we will replace this 18 with 18. Okay. And we will remove, for next window, we will remove 5 from this. So it will become 13 now. Again, we will move forward. Okay. So now I is at 7. J is at 3. Okay. So we'll add 3, which is 16. 16 is not bigger than 18. So we will not replace our maximum answer. Okay. This is satisfying the condition of j minus I plus 1 is equal to 3 every time, as you can see. So it will not. So we'll remove what? 16 minus 7 will remove. So it will be 9. Again, we will move this to one step ahead, both I and j. So whenever is satisfying, we will moving both I and j. Okay. So now we will add 2 to this. So it will be 11, and we will remove 11 is not bigger than 18. Okay, fine. We'll not replace. We'll remove 6 from it. So it will be 5. And we will move one step forward. This is 5. So we'll add 5 to this. So our sum will be 10. 10 plus 10 and 18. No. And we'll remove 3 from it. So it will be 7. We'll move one step ahead. Now j has become n. So j is not less than n. J become equal to n. So we'll move out of this. And our maxi is 18. So we'll return. Okay. So this is this sub array of size 3. 5 plus 7 plus 6 is what our answer. Clear? Okay. So without just wasting time, our time complexity will always be what? Order of n. Clear? Okay. Let's just move to 2 questions which we'll be solving today. Okay. So we are given a question where a swap is defined as taking 2 distinct positions in an array and swapping the values in them. Now we are given a circular array, okay, where we consider the first and last element to be adjacent. Circular means this 0 and this 0 is considered to be adjacent. And we are given one binary circular array nouns. We have to return the minimum number of swaps required to group all ones present in the array together at any location. So we have to group all ones, and how many minimum number of swaps required for that we need to find. Okay. So I mean, we have to find, let's say there are 3 ones over here. Okay. Then we have to check what? How we will take this as the fixed sliding window? Because if there are three ones, there are total three ones present in the array, then we have to check in every three size window that if I take this three size of window, how many swaps I have to do? Two swaps. How did I know? Because this two are zero, only one is one. So I have to swap this zero with any of the one I can swap, and I have to swap this zero with any of the one. I could take this three window, 101. So I need to swap only 10. If I take 011 window, I need to swap only one window, only one number. Okay, so minimum swaps, even if I take 110, there also I need to swap this 10 with this one I can do, and I got my answer. So we have to find those minimum number of swaps which is required to group all the ones together. Okay, now consider this example. Uh, so okay, so this is example where we do not need any swap. How did I know? Because this one, as they have said, this is binary circular array. So this one is already in adjacent with this one. So it means this all three ones are together only. This all three ones are together only. So how we will calculate for this type of questions? I mean, how we will do? Let's say if I take three size window also, then for this I need two swaps. For this I need all three swaps. For this also I need all three swaps. For this I need two swaps. And for the last case I need one swap. So minimum answer I could get is one swap I need. But actually the answer is zero because I do not need any swap. Right? So what I can check? I can also check how many swaps I need to make all zeros together. So here all zeros are together only. So we do not need any swaps because they are in between only. What I can conclude out of this? Either one is in the circular array, okay, either one is in the circular array, or zeros are in the circular array, like in the above example. Here zero is the part of circular array. So last is zero and first is zero. And here last is one and first is one. So this could be two cases. And if last is one and first is zero, I mean the same only. No need of that. That is simple case. So what I need to check? I need to check how many minimum number of swaps to make all zeros together, and how many minimum number of swaps needed to make ones together. And then I have to return minimum of both. So minimum swaps to make zeros together, and minimum swaps to make ones together. Okay, so in this case what will be my answer? So for zero I have to take four size window. Okay, to check for how many swaps I need to make zeros together, I need to check four size window. For four size window, if I take this four, I do not need any swap, so that will be zero. So if I want to make, if I check for one, we have seen that this is the optimal answer, 0 1 1. And for here it's 0. Minimum of 1 and 0 will be returned, which is 0. So I do not need any swaps. Means zeros are already together. That itself means that ones are already together. Cool. So that's the only part we have to do. Now we will make the sliding window as the function, and we will pass the variables, parameters in that function in such a way that we will satisfy both these things generically. So let's just switch to the code and you will get to know there itself. Fine. So I'll just take one this thing, and our basic case will be there are no ones at all, or there are all ones at all. Then we do not need any swaps. Our answer will be zero only in that case. Okay. Our answer will be zero only in that case. So we'll first count the number of ones. Okay. So let's just count the number of ones. We will need that for making the size. So here the size of window k is not given explicitly. We need to find that this is the size of the window. Okay, if my nums of I is equal to 1, I'll do count plus plus. So there are count number of ones in my window, so there will be n minus count number of zeros. So when I will do sliding window for 0, I'll pass n minus count as the window size. Okay, but if this count is 0 or this count is n, that means I have no ones or all ones, then my answer will be 0. Fine. So we will calculate one sliding window. So this is our sliding window function. Okay, we'll pass nums, we will pass window size k, and we will pass the number. what this number is, either we have to find for the zeros together or ones together. I'll make this function generic. Okay, as we have defined, we'll do I and j. N will be this nums dot size. Now we have to find the minimum answer over here. So let's keep our minimum answer to be n plus 1, because whole window can also be answer n. More than that, n plus 1 is the maximum, is what we can get. So I have put this as n plus 1 as of now. Whenever we have to find minimum answer, make it as max as possible. Whenever we have to find maximum answer, make it as minimum as possible. Okay. Now what we can do, while j less than n, what I need to check, we'll need number of swaps. So I'll take the swaps as 0 as of now. So if my nums of j is not equal to what I want, then I need to do the swap. So my swaps will increase. Okay, this is our calculation part. Now as per our template, if j minus I plus 1 less than k, we'll do nothing. We'll just move the loop. If it is equal to k, okay, what will be my minimum answer? Will be minimum of minimum answer and how many swaps, number of swaps we have calculated. Now what I did, I increased the swaps if it is not equal to num. Okay, so now what we have to do, so if nums of I is not equal to num, I'll do swaps minus minus in this case. I'll do swaps minus minus in this case. Okay, and that means if I'm moving this loop, okay, and if there is a k is equal to 3, I have done this thing. Now when I am at j is at my this index, second index, and I is my first index. So 2 minus 0 plus 1 is 3, which is satisfying. Okay, and I'm counting for ones. So here this I is 1 and this is also 1. So we do not need to decrease the swaps. But if at all this is 0, then I'm not taking the 0 for this window. So I will decrease my swaps because I have considered that swap when I was taking that window. Okay, I hope you got it. So opposite is what we have to do for nums I. Done. We will do I plus plus j plus plus. And we will return what? This minimum answer what we have got. Now what we have to do? We will do int swaps or int count of 1 means making ones together. Okay, I'm grouping ones together. So I'll be calling the sliding window function for this nums array. How many window size will be count and this num will be 1. And if I have to group zeros together, my sliding window will look like n minus count and 0. Okay, so I'll of course return what? Minimum of this 2. This way my circularity will be also taken into consideration. I hope you got it. Clear? This is a very good question of fixed size sliding window, wherein you have to determine what could be the size of the window. Let's just move to the next question. Okay, so our next question is, given an array and a positive integer k, we need to find the first negative integer for each and every window of continuous subarray of size k. So you are given fixed size k over here. So it could be verified that this is the fixed size window question. Okay, and we have to find the first negative integer for each and every window of size k. So let's say this is the 2 size window. So from minus 8 and 2, minus 8. For 2 and 3, no negative numbers are there. So 0. For 3 and minus 6, first negative number is minus 6. And for minus 6 and 10 also, minus 6. So in such a type of questions where you will be asked first negative integer, or you will be asked from every subarray, some specific conditions are given where you will see that okay, I have to do first this type of thing. For all subarray of size k, I have to do first negative, first positive, okay, or maximum of all. Then in such a type of cases, you can use either q or dq depending on the question. So here I can see that okay, what I need to do, I just need to focus on the negative numbers. Okay, but let's say I have taken this minus 8 and 2. This could be the better example. Let's say I have taken 12 minus 1 and 7 minus 7 as my first this thing. Okay, what I'll do, in my queue, let's say I'll take to queue. In my queue, I'll push -1 and -7. Why? Because for this window, it could be possible that -7 could not be the answer because -1 is already there. But if I'll move to this window, -7, 8, and -15, then my -7 could be the answer. So the negative number, which is not the answer for first two windows, could be the answer for the third window. It could be possible. So we need to store all such numbers. So in this type of cases, we will use Q or DQ. So now if I'm taking this window, okay, I'll store -1 and -7. Now how we will remove from the queue? So if I satisfy the condition of j minus I plus 1 is equal to k, I'll just check that whatever is my front value in the queue, is it same as whatever is my I value? If it is same, then I'll pop it out. Okay. So if at all I come to this point, okay, and my I is at -1, -7, and 8. If at all I'm at this point, I have stored my -1 as the answer. So always my queue's front value will be the first negative integer. That you already know. Okay. This is very common question. So my queue's front integer, first integer or front integer, whatever is stored in my queue, will be my answer for sure. Okay, because that is the first. The property of queue is that only. Now when I am at this point, it is satisfying. Now I'll check I is at -1. Okay, and my front value is also -1. So I'll remove that. So that in my next window, my front value does not remain -1. So I'll not put that as my answer. Because in my next window, -1 should not come. So now -7 will be the front answer. Of course, I'll push -15 also in the queue, but -7 is the front answer. So that will be my answer for this case. Again, I will be at -7. So I'll remove it because that is only the queue dot front and that is only my I value. So I'll remove -7 and I'll move ahead with 8, -15, and 30. So now my front value will be -15. In this case, my I will be at 8 and my front value is -15, which is not matching. So still my -15 could be the value for the next window. Could be possible. So I'll not remove. So for the next window also the answer could be -15 only. Then I'll remove because now it is at I. I hope I'm clear. Okay. So I do not need to explain it in much detail. Let's just quickly code it and you will get it. We will have one I0 and J0. We will need one Q to store this all things. Okay. So I have my Q. We'll also need one vector of int answer to store the answer array. Okay. So in this type of cases also where we need to return back the full answer for all window of size k, we'll use sliding window. We'll take while j less than n, what we will do, if nums of j is lesser than 0, means it's negative, I'll push that in my queue. So this is the calculation part. Now what we have to do, as per our template, if it is less than k, just move it. If it is equal to k, we'll do the answer part. So answer is what? So we need to check that there should be something in the queue. If there are no negative integers, they have clearly mentioned return 0 for that window. So if queue dot empty, this means I have nothing in my queue, then I'll push back what? 0. Else I'll push what? Front value, q dot front. Now we will check if this front value is equal to what is there at my ith index. If those are two things matching, then I'll what do? I'll pop it out. I will pop it out. Okay. So this is the sliding part. And every time what we have to do? I plus plus j plus plus. Clear? I'll return this answer. Okay. Clear? So this way we are done with the fixed size sliding window. Next we will be covering is the variable size. I have provided the notes, handwritten notes in the description and an ample amount of questions of fixed size sliding window to practice for you. So just practice it and get it done. Next we will be covering is the variable size and there are lots of questions and variations in that too.